Hello biologists, this is quiz 2.07, a review of all about water and the biology of water. Water exhibits some very important properties for biology. One of these is hydrogen bonds. It's a slightly charged molecule because the electrons from hydrogen and oxygen are not shared equally. The electrons from hydrogen spend more time with oxygen. So within the water molecule itself, it's a covalent bond, and the electrons are shared, but they're not shared equally, so that creates poles in the water molecule, and I'll show you what that looks like in just a moment. Water sticks to itself because of the polarity. It's kind of like a magnet. Water's not magnetic, but it has poles like a magnet. Water's special properties are important to many aspects of biology. The oxygen attracts those electrons more strongly, so the oxygen end of the molecule becomes more negative. You can see in this picture the oxygen end of every water molecule. Here's the oxygen, and here it's more negative because there are more electrons. Remember, electrons have a negative charge, so if there's slightly more electrons on the oxygen end, it's going to be more negative, and therefore it's going to be charged. Because it's a charged molecule, these guys stick together. The positive end gets attracted to the negative end, and the negative ends get attracted to the positive ends of other molecules, right here. The hydrogen is positive. These white things are hydrogens because they have fewer electrons, so they're a little bit more positive than the oxygen. So right here, if we had to label the ends of the molecules positive and negative, I bet that you would label the oxygen end of things negative because in the covalent bond within the water molecule, the electrons spend more time on the oxygen end. So the oxygen end of the molecule becomes negative. And there you go. You can see there's a pole. This end becomes positive because the hydrogens don't share those electrons equally in the covalent bond within the water molecule. The covalent bond is within, between oxygen and hydrogen. The hydrogen bonds are between the molecules. Hydrogen bonds are between water molecules. Those hydrogen bonds are what makes water stick together so well. That property is called cohesion, and it's very important for biology. Water sticks to itself and would make perfectly round droplets if it weren't for gravity. Here, this is in microgravity in space. You can see water does make great round droplets. Water also sticks to other things, and this is called cohesion. Cohesion is important for trees because water sticks to the inside of the little tubes in trees, and this is called adhesion. And this particular aspect of adhesion, where water sticks to the inside of little tubes and is drawn up, is called the capillary effect. And that's very important to trees because water is naturally drawn up from the ground to the leaves. The tree above me here depends on adhesion to get water from the roots to the leaves. You can see those little tiny tubes here really well in celery. And this is the capillary effect. And adhesion, the property of water adhesion, is responsible for the capillary effect. Water rising in little tubes like that. If you've had blood drawn and they've picked your finger and they've used a little glass tube to pull up some blood, you've seen the capillary effect. So why is hydrogen bonding between water molecules so important? Remember, the hydrogen bonds are between the molecules. Is it a magnet? Does it stick to itself and other molecules? Is it made of hydrogen and oxygen? Does it behave strangely in microgravity? Or, I don't know, but I'm participating. I bet that you picked B. It sticks to itself and other molecules. When it sticks to itself, it's called cohesion. And when it sticks to other molecules or other substances, it's called adhesion. Like when you add something else, it's adhesion. Water is very important to biology as well because it's a universal solvent. Ionic bonds, like those in sodium chloride, potassium chloride, and magnesium chloride bond, they dissolve really well in water, and I'll show you why that is in a moment in the next slide. The polar nature of the water molecule makes it easy to break those ionic bonds. And the ions are key for cells. These ions are needed for the cell to function properly. We'll talk about which ions in a second. Here you can see, here's the water molecules, and that polarity of the water molecule, the negative side is surrounding the positive sodium, and the positive side of water, the hydrogen side, is surrounding the negative chlorine, and it's pulling the sodium and the chlorine apart. This is a salt crystal here. The green ones are chlorine, the gray are sodium, and it's pulling those atoms apart, breaking the ionic bonds, so the sodium ions and the chlorine ions can become dissolved in water and participate in really important reactions in biology. Water is called the universal solvent, especially for these important ions for your body. Sodium, potassium, and calcium are electrolytes. Electrolytes participate in many chemical reactions in the cell. They create electrical potential in your cell just like a battery. If you're an athlete, you may have had electrolyte drinks because when you sweat, you lose these ions. And when you take them back in by eating fresh fruit or having some juice or drinking a sports drink, you basically kind of recharge your batteries. You make your batteries work better. Your cells, because your cells are how you get energy. Remember, your mitochondria produce energy, but you don't need to know that for this quiz. You do need to know why water is so important to life. It's not organic, so that's not a good choice. It does have protons, neutrons, and electrons, but every atom does. And every molecule as well, and water is a molecule. Many important reactions happen in water. We talked about how important electrolytes are and their reactions within the cell. We have many oceans on Earth, or E, you might just not know, but I'm going to tell you that many important reactions happen in water, in the watery environment of the cell, so water is very critical to the health of cells, and hence the health of us and all the other living creatures. The water in our cells is much like seawater, and our blood and other body fluids contain concentrations of ions, sodium, potassium, magnesium, calcium, that are similar to seawater. This supports the theory of evolution, that life came out of the sea. Thanks for watching. Now go take quiz 2.07.